The whole function of the determinant is to help you determine whether or not these functions have an inverse or not. So actually, that's going to be our whole focus today in this last section. Is we're going to be finding determinants like crazy. And then towards the end, I'm going to show you one last way to solve systems of equations. That's how chapters 7 and 8 go so well together. One last way to do systems of equations using nothing but determinants. But first off, you see how this matrix is in like an absolute value? That's how they ask for a determinant. That's the symbol for give us the determinant of. So like these 5 problems all just say, even if the directions weren't there, the absolute value in the matrix just needs find the determinant. And all of these are going to be done the same way. I picked off what I believe to be the hardest one for your DOM. But those top 4 are the same thing, just done a little easier. We'll look at maybe one of them. Number 5, AD minus BC. Your determinant is 0. What does it mean when your determinant is 0? No inverse. Good. That's pretty much the entire point. Questions about this slide? All right. Skipping on ahead. All right. I'm sorry. This is 8.5. 8.5. Kramer's rule. There's one last method for finding the solution to a system of equations, and that is called Kramer's rule, which is, it simply says, now this is a 2x2 determinant. Matrix. It says, if you find the determinant of your matrix, D, we're going to call it D. And then if you find 2 subdeterminants, which are the exact same thing, which I'll show you how to do in just a second, the solution will simply be dx over d will be your x solution, and dy over d will be your y solution, and you will have solved the system of equations. First off, what the heck is dx and dy? Dx is simply, well, what's our matrix here? Isn't it 1, 1, 1, negative 1, and then it's equaling 7, 3? I left out the x and y right here, but, I think you get it. All right. So first off, for number 11, what is our determinant? Negative 1 minus 1, is that negative 2? So I'm going to write that over here next to D. Negative 2, that's my overall determinant. dx, and this is quite simple, and this is the way it's going to be all day today, whether it's a 2x2, 3x3, whatever. dx, you just replace the x column where you had your x values, 1, 1, and you replace that with the answers, 7, 3. And then you find that determinant. No, the whole first line goes on the top. It goes pretty much by row. And this is the x column, the y column, and had it been a 3x3, that'd be the z column. So you take out your x's and put in the answers. Now find that determinant. Negative 7 minus 3, is that negative 10? That's your dx. Found the determinant again. Once I substituted my x column with the answers, you just find the determinant of that matrix. dx is negative 10. That was the original determinant of the matrix we started with. AD minus BC, just like the DOM and the last thing. Yeah. Now, dy, guess where we're going to plug 7 and 3 now? Into the y column. Right. And then you're going to find that determinant. 3 minus 7, was that negative 4? The solution to this system is now dx over d. dx over d is what? 5. And dy over d is 2. So x is 5 and y is 2. And if you come back over here, sure enough, that does work. That's Kramer's rule. I don't know who Kramer is, and I don't know how he came up with that, but it's pretty cool. And that's pretty much what we're doing all day. Oh, good question. Basically, if you get a solution at all, in other words, if your original determinant exists, it's immediately going to be consistent. you know what? Don't even worry about that step. That's a worthless step for this. Essentially, you can solve it. One second. You can solve it if you have a determinant, and you cannot if it doesn't. What? You're saying? Do you have a question? Yep. That's exactly right. Now, the only thing about it, there being another variable is the determinant itself is a little trickier to find. Because I've only shown you how to find a 2 by 2 determinant, A, D, and B, C. But I'll show you 3 by 3 in just a second. 21. Is it more complicated because it's not written as neatly? So you'll have to rewrite it a little neater. Oh, absolutely. Let's do that. You want variables on one side, numbers on the other. So that's going to be 2x minus 3y equals 2. 5x plus 4y equals 51. I just added that over, subtracted that over. So this one, it'd be 2, negative 3, 5, 4 for your original. And what's my d value? 8 minus a negative 15, so 8 plus 15, 23. Now we need dx. I'm going to take out 2 and 5 and plug in 2 and 5. That's kind of crazy. Oh, oops, 1. 251. 8 minus 153. 145. Negative 145. Alright. Now I replace my x and y and put 2 and 51 in for my y values. So that's 102 minus 10. 141. And if you get an ugly fraction, sorry, I apologize. So, your x value, dx over d, does that reduce? negative 145 over 23? I don't think so. I don't. Make sure I did that right. Okay, so it's just ugly, unless I did something wrong, which is possible, but we're going to keep on marching. Over 23, and your y value, 92 over 23 is 4. I bet you anything this is wrong. Let's see, we can check. We'll plug it back in. If y is 4, that's going to be 12 plus 2 equals 2x. 14 equals 2x. I should have gotten 7. And since that's 7, this should have been 151. Yeah. Yes, x's, y's, numbers. Yeah, have to. Let's see. This is what it was originally, right? 102. No, I did it for the y column again. Oops. 251, negative 3, 4. It was 8 minus a negative. Thanks. No, this is dx. I'm looking for dx again because I know it was wrong. Yeah. So it's 8 minus a negative 153. So 8 plus 153. Yeah, which is 161. That makes it better. Now it reduces to 7. But here's the thing. If it's ugly and the other one's not, just plug in the other one and you can find it like that. So I knew this was wrong, so I could just plug 4 back in. 14 equals 2x divided by 2. Boom, x is 7. So if you're getting an ugly one for one and not the other, who cares? Just plug it in and solve for it the easier way. Did I? Oops. Yeah, it was minus a negative. I apologize. Yeah, I guess you could. Yes, you can. And when we get to a 3 by 3 in the next slide, you can find 2 of them and just find the third one if you'd like. Sure. All right. Questions about that? Write out your equations. You're freezing. Would you like to move somewhere? Lots of empty tables. Okay. Now, third order determinants. There are 2 ways to do these. You only have to do one. You do not have to know how to do both. There are 2 ways. I will show you the way that is normally more popular first. Then I'll show you the other way, and I'll let you choose which one you do. The only thing to remember is when I do examples, I'm not going to do it both ways every time. So I'm just going to alternate when I do examples after I show you both ways. The first way to do it, let's find the determinant for number 27. The first way to find a determinant of a third ordered matrix you write the first two rows right next to your original matrix. See that? How I just wrote these columns. First two columns next to the original matrix. Now, the slash method. Start here, multiply at a diagonal. 3 times 1 times negative 1. Negative 3. 0 times negative 5 times 2. 0. 0 times 2 times 5. 0. You add all those together. Then you're going to subtract the product of these three diagonals. Now you start in the bottom left and go upward. 2 times 1 times 0. 5 times negative 5 times 3. Negative 75. Negative 1 times 2 times 0. So, negative 3 plus 75. And our determinant is 72. Same principles. If you get 0, cannot have an inverse or a solution to the equation. This is just the diagonal. Yeah, that's it. That's the diagonal method. That's normally the popular way to go.
So you always write the first two, even if it's going to be a 1 by 4?
Well, no. Good question. No. If it's a 4 by 4, you'd write the next 3 columns, although I'm not going to ask you to do that. 3 by 3 is as high as we're going to for this. Okay, the other method, which I will do for number 29.
Typically, anything in your lifetime with the letter H to go over the A at the time, then your lifetime starting with the letter H to go over the A.
Yes, 72 is the answer. 29, I'll do the other way. Here's the other method. Okay, you always go across. Actually, it's not entirely true. I'm going to start with the top row. Normally, you go with the top row. 3, negative 1, 0. It's always positive, negative, positive. Not necessarily, but it's the sign that it has, an opposite sign, the sign that it has. So had this been a negative 3 and negative 1, it would have been negative 3, positive 1. You always take the signs that they have and the opposite of the sign that it has. And you're going to multiply that, all three of those, by little mini matrices. Now, as you can tell, this last one's just going to be 0, because 0 times anything is 0, but nonetheless. All right, for 3, cross off everything in its row and column, and what's left is called its minor. And that goes in a little 2 by 2 matrix right here. Again, if you like the other method, you don't have to do this. But you always take the method here, when you do it, you always take the opposite sign of the second one. Always. Okay? All right. So, then I get the minor for my 1. Cross out everything in its row and column, and its minor is negative 3, 0, negative 1, negative 5. You don't have to. You don't have to. The minor for the 0, negative 3, 4, negative 1, 3. Now you just find their little mini determinants. Negative 20 minus 0 is negative 20. Negative 3 times negative 5 is 15 minus 0. 0 times anything is 0, so who cares? Negative 60 minus 15, and that determinant is negative 75. Either one you wish to do. The one perk to using that method, you know how I said normally people just go with the first row if everything's numbers, but here's the perk to using that method if you choose to do so. A 3 by 3 has this, don't ask me why it's called this, because I don't even know. But it's called like a polarity field, okay? Positive, negative, positive. It basically alternates all the way through. You can start with whichever 3, with any column or row that you want. And just remember, like I chose the first row, so I needed the sign, the opposite sign, and the sign, hence the negative 1 here. Well, like say this one, see how it has 2 zeros? I could have chosen that column to use originally. And had I done so, it would go regular sign, opposite sign, regular sign. It would have been 0 plus my first minor minus, just because it's negative, 0 times my second minor plus negative 5 times my third minor. And as you can tell, the beauty of doing it like this is if you have zeros, Now, really, the determinant of this whole thing is just negative 5 times this minor. 12 minus negative 3 is 15. Negative 5 is 15. Negative 75. So either method you can use. Raise your hand if you prefer the diagonals method. Raise your hand if you prefer that method. So 1/2 to 7. So most of you don't care. Okay. Well, then I'll probably just stick with diagonals, but at any time during an example, if you want to see the other method, just let me know. Okay, so why don't you try to find the determinants of number 31, and I'll see if you get the right thing. 31. Excellent. Now I'll leave that example at the top for you to reference. The sum of the first 3 minus the sum of the third 3. Second 3. You're finding the determinant of number 31. The answer is going to be on the board. I think this is right. Did anybody get 0? Good. 8 minus 8. Again, if your determinant is 0, you can't have an inverse, and also it means your system of equations can't be solved. It means it's not going to have an answer. So one thing you should take out of today, if nothing else, on your next test, when you have a 3x3 system, even if you want to go back and do it the really old algebra way from section 7.2, if you were to make it into a matrix and find its determinant, you could find out really early on whether it'll even have an inverse or a solution or not. Yeah.
The first one is negative, isn't it? Negative 10 plus negative
Negative 10 minus 6 plus 8.
That's negative 8. And then the second one is negative 9.
So I just got them backwards. Negative 8 minus negative 8. Yeah, I apologize. All right. Questions about finding the determinants? All right. The last slide is just putting those two things together. We're now going to use that to find the solution of a 3x3. Now, I will tell you this. On the next test, there are going to be questions where I say basically solve a system of equations, and I don't care what method you use. We've learned so many methods to solve these things now, and I don't really care too much which one you use most of the time. There is a way to do what we're doing right now. If you think this is the easiest way we've learned, there is a way to do this with 4x4, but a 4x4 determinant is more complicated, and I'm not going to subject everybody to that, but it is in the book. So if you like this method and you think, boy, I would much rather do this than what we've been doing to solve 4x4s, you're welcome to do so. There's examples in the book, and I will help you with that at tutoring sometime, but I'm not going to teach that because I'd prefer you just do these methods. But I don't care. That is available to you if you wish to do that. All right. Which one you want to do? No, I think it's more complicated than that. I'll have to look at it, though. It's been a while since I've done it. 33? All right. 1, 1, 1, 2, negative 1, 1, negative 1, 3, negative 1, and then our answer column is 0, negative 1, 8. Because the lower portion of my board is so horrible, I'm going to work horizontally. So we're looking for, stop it. We're looking for d, dx, and dy, and dz. Because now we have 3 variables. And it's going to work the exact same as the last ones did. First off, I'm going to move the 0. You know, it's right here. We don't need to remind ourselves what it is. First thing we need to find is normal d. So we write out the first 2 rows. And I'm assuming the consensus is do the diagonal method. So that's what we'll do. Diagonal method. 1 plus 1 plus 6 minus, you go the other way. 1, whoa, almost, plus 3 minus 2. So you've got 8 minus 2, which is 6. So D is 6. Any questions about how we found D? No. You just take whatever it is. It's always the first 3 minus the sum of the second 3. Always. That one you don't have to do any of that kind of stuff. In fact, looking at this, the only one where I think the second method would be easier is 39, because 39 has 0 sprinkled in. But again, that's up to you. Yeah.
How about the second one? In the first parenthesis, was supposed to be negative 1. Because shouldn't that coefficient of b be minus 1?
Right here?
Like,
Hold on.
Next to it. Next to it, that next one. Shouldn't that be negative 1?
Oop, yes. This was a negative 1. Shnikes. That's alright. It's just going to change this number to a negative 1 and this one to a negative. No, that one was already. Looks like this is the only one to touch. So that's the only thing that's going to change right there. I rewrote this row right here, so that should have been a negative 1. So that would have been, oh, I see what you're saying. This one stays the same. This one's the negative. Yeah, okay. Regardless, that's was that 4? 6 minus 2, 4. Okay. All right, dx. Now we're going to find dx. Ooh, reduce my eraser. So I'm just going to redo it all right here so that I can keep all my material on the board. So I'm replacing the first row with my answer row for dx. I'm replacing my x column with the answers. Now when I rewrite my first 2 rows over here to the side, same thing. I keep using my changed matrix. dx. Determinant 0 minus 8 minus 3 minus 8 plus 0 plus 1. So that's negative 11 minus 9. Was that negative 20? Into the x column, yeah, for dx. X column, y column, z column. Yes, ma'am. Yes? Thank you. You want to get the assignment now or just get it online later? Okay. Well, we're not there yet. It will be. We're going to do all that last. All right, for dy, here we go. Now we're going to find dy. Same exact method. So 1, 2, negative 1. Now we replace the y column with the answers. 1, 2, negative 1. Really like all the math chat going on. Really like it. There you go. By all means. Right. Thank you. I don't know. I'm just making it up as I go. All right, here we go. Because it was a negative in the. I just miswrote it. Here we go. 1 plus 0 minus 16 minus 1 minus 8 minus, well, it's just because it's negative, that's all. Plus a negative, but I like to just make it into a minus. So it's negative 15. Let's see, this is negative 7. That's not right, is it? Negative, no, it's not right. It's negative 9. Is that right? All right. Okay. I'm hoping z is a half too, or we did something wrong. But like we said a second ago, let's say we get x and z right. Rather than re-look for y, we can just plug them in and solve for y. In fact, on 39, yes it does. Which makes this a 0. You're all over this, and I'm glad you are, because I am not all over this at all. So that makes this negative 8. Well, that's going to make it look much prettier. Now, you could stop right here and plug those two in and solve for z, if you want to. But we'll go ahead and finish out the problem. What? Well, we'll see. Let's see. All right, so 1, 2, negative 1, 1, negative 1, 3, 0, negative 1, negative 8, 1, 2, negative 1, 1, negative 1, 3. Yes, you could have. Yes, you could have. So, diagonals. That's 8 plus 1 plus 0 minus 0 minus 3 minus 16. So that's 9 minus a negative 19, 18, 19, which gives us 28. Bam. So x is negative 5, y is negative 2, and z is 7. Questions about any step, why, how, anything? Any of those question words? You always, yeah, dx over d, dy over d, dz over d. Please note, 39 is actually the easiest one on the page. Why? Because once you do this and find just one of your variables, let's say we find x by doing this, plug x in, you can solve for both z and y right there. If you have zeros anywhere, that's going to make these even easier to solve because you have less steps. So don't overwork yourself. Actually, on 35, same thing. Once you find x, you can find y. Once you have x and y, you can find z. For those, yes. 33 you couldn't. You had to find at least 2. Okay. Yes, we are done.